All right, so we're going to look at J8, find the number of solutions. So I wanted to make some things explicit. When we were solving equations before, we would always come up with x was a number, f was a number, the variable equaled some value. So when that happens, we have one solution, meaning there is no other number that could make the equation true. And that you would see when you're checking your value that you get for your variable back inside your equation. Now, sometimes what happens is that you go ahead and solve the equation and you end up with some term equaling the same term. So I have an example for you, like if it were 4 equals 4, or 5 equals 5, or 7 equals 7. That would always be true. In other words, it wouldn't matter what number you used inside the equation, that one value on one side would always equal the same value on the other side of the equation. That would be called infinitely many solutions, because we could choose from any number and that would make the equation true. Then there's sometimes where you end up where you have a number that equals another number, but they are not the same, and nothing you could ever do to either side would make them the same. So we say that's never true, and if that's the case, there is absolutely no solution to the equation. So with that in mind, we're going to go through J8. So here we have 0 is equal to s minus s. Well, if I have one s and I take it away, then obviously that's 0 equals 0. So this would be infinitely many solutions. Let's look at number 2. We have 0 is equal to 2j minus 2j. So again, if I have 2 of something and I take those away, 0 equals 0. So again, that would be infinitely many solutions. And you're going to see something like this as well when we start talking about systems of equations. This idea presents itself where you have one point where the lines cross, that would be one solution. If they're parallel like train tracks, they'll never meet. That would be no solution. If I had one line right on top of another line, that would be infinitely many solutions, because every point would make that line true. So this is a precursor of that. Now on number 3, we have 8 minus 4m equals negative 4m. Well, if I go back to solving equations, I know that I need to isolate my variable. So I'm going to add 4m to both sides of the equation. And when I do that, I'm left with 8 is equal to 0. Well, that will never be true. And there's nothing that you could do to either side of this equation to ever make it true. So we're going to say that that would be no solution. Number 4, we have negative 7h plus 10h equals 3h. Well, if we combine like terms here, we see that 10 has the advantage by 3, and 10 is positive, so our 3 will be positive. So we have 3h equals 3h. Now I really don't have to continue to solve because these are the same. But just in case you're needing to do that, well, I could divide by 3 on both sides of the equation, and that would give me h equals h. Well, h equaling h, there's no way that can't be true. So this would be infinitely many solutions. Number 5, we have negative 5 minus 4j equals negative 4j. Well, we want to isolate the variables on one side, so we're going to add 4j to both sides of the equation, and that would give us negative 5 is equal to 0. Well, is this equation an identity? In other words, does one side equal the other? Well, in this case, no, negative 5 does not equal 0, so we would say no, this is not an identity. Let's look at number 6. That's 9 plus 10w equals negative 6w minus 7. Well, I'm going to go ahead and move the 6w to the other side of the equal sign because 10 is larger and it's positive. So I have 9 plus 16w is equal to negative 7. Then I'm going to subtract 9 from both sides of the equation. And that leaves me with 16w equals negative 16. I'm going to divide by 16 on both sides of the equation. 16w divided by 16 leaves me with 1w, and w in this case would equal negative 1. So I have only one solution because I know what the value of w is. Number 7, we've got 5z plus 1 equals 5z. Well, if I subtract 5z from both sides of the equation, I end up with 1 equals 0. That will never be true, so this would be no solution. All right, we've got number 8. And this is this equation an identity? So we have negative 1 plus 10y minus 8 is equal to negative 9 plus 10y. Identity again would be where you have infinitely many solutions. So we've got negative 1. Let's go ahead and combine like terms so we can simplify the left side. Negative 1, negative 8 are on the same team, so this would be negative 9 plus 10y equals negative 9 plus 10y. Well, we really don't need to go any further because one side equals the other. So we can say yes, this is definitely an identity. Look at number 9. Negative 3t is equal to 3t minus 6t. Well, 3t minus 6t, or you can think of it as negative 6t plus 3t. Either way, that would be negative 3t. Both sides equal each other, so how many solutions does this have? It would have infinitely many solutions. All right, let's go ahead and look at number 10. We have negative 9 minus 2q equals 4q plus 9. Now you may notice that when the coefficients of the variables are different, that we end up with a solution. Let's see if we can test that hypothesis. So 4 is larger, 2 is smaller, so I'm going to move 2q to the other side of the equation by adding it to both sides. So we have negative 9 equals 6q plus 9. And I'm going to subtract 9 from both sides of the equation. And that gives me 6q equals negative 18. Well, if I divide by 6 on both sides of the equation, q would equal negative 3. And so because q equals negative 3, we would say we have one solution. We have number 10, negative 7g minus 10 equals negative 7g. We want the g's on one side, so I'm going to add 7g to both sides of the equation. And we have negative 10 equals 0. Well, of course, that's not true, so there is no solution. And it says, is it an identity? Well, no, it's not, because one side is not the same as the other. Number 11. We have 8h minus 3 equals negative 3 plus 8h. So if you look at this, notice that these are exactly the same. 8h minus 3, I could change this around to 8h minus 3. So we'll go ahead and test it though. We're going to subtract 8h from both sides of the equation. And I'm left with negative 3 equals negative 3. Well, they're the same. So yes, this would be an identity. Number 12, negative 20 minus 17y is equal to negative 2 minus 18 minus 17y. So if you look at this, let's look at the right side. Let's simplify that. We have negative 2 minus 18. They're on the same team, so let's just add them together. So we have negative 20 minus 17y. They're exactly the same. So this would be infinitely many solutions. We don't even need to continue to solve it, because no matter what we do, everything is going to be the same. Number 13, 0 equals 8k minus 8k. Well, if I have 8k's of something and I take those same 8k's away, I have 0. So 0 equals 0. Is that an identity? Yes, it would be an identity because both sides of the equation are the same. So I hope you go ahead and continue on. Try to get up to a 90 or even 100. I know you can do it. All right, I'll talk to you later. Bye-bye.